Great, thanks a lot, Ben. Yeah, as Ben said, I'm Niall Deehan. I'm a consultant here at Camunda, and I'll be joined by my colleague Daniel. So just to give you an idea of what we're going to be doing for the next hour, I'm going to start by showing you guys the basics of Camunda. Just going to show you what it's all about and describe a bit. And then after about 30 minutes of that, I'm going to pass it on to Daniel, who's going to describe the integration between Camunda and Hazelcast. So I'm going to start with a few slides, but don't be too worried about that because there only are a few of them, and then I'll be going on to actually describing how to create things with Camunda. So if you guys can see the slide, the first one is just basically what Camunda is for those unfamiliar with it. So Camunda currently is an engine that can that orchestrates workflows through using BPMN, CMN, and in the not too distant future, DMN as well. So what that means is that we use BPMN modeling tool, and we make the models created in BPMN directly executable, which means you can sort of attach code and program flows so they go a certain direction, that sort of thing. So the reason why we have these three standards here implemented, BPMN is intended for predictable and orchestrated workflows, things that you can do. You can create in a model environment that are repeatable, and that is the vast majority of cases for workflows. So, but of course, we also have added the CMMN standard for cases, for cases and in options where perhaps the flow isn't necessarily so predictable, something where a knowledge worker, we would say, would need to act. So in those sort of cases, we give the user an option of certain cases they can perform and certain actions they can perform. And as opposed to an engine controlling what they do next, the user has a lot more power. Now, in November, we'll have our release of DMN, which is the new decision model and notation standard from the OMG. And this will allow us to finally be able to implement rules, essentially business rules, within our own engine. And that standard is, I think, relatively new to the OMG. I think it's only in beta currently, but we should be we pretty much have the engine in pretty good shape in terms of executing DMN. Okay, so next up. So I want to give you a technical overview of what you'll be looking at today, and just while we do the demo, it might be useful to see what you're actually what we're actually demonstrating. So we'll start here in this little where the engine is. So the engine that actually sort of controls the BPMN and CMN, on top of that has a REST API, which is built on a Java API. And we have a few different tools there, task list, cockpit, and admin, that are UI tools that can be used by users to interact with the engine. So task list, for instance, is used for users who actually act within the process. Cockpit is used as more of an administrative tool for organizing and reporting on processes. You can also see that we have the Eclipse modeler there at the bottom left, where you can create models that can then be made executable. And we also have Cycle, where we can convert third-party models into, synchronize third-party models so that they can be then edited and made executable. So if you guys are new to this idea of executable models, I'm going to be essentially creating that today and showing you how you're able to go from something that an analyst may design to something that a program actually executes. And the best part is that it doesn't actually change at all between those two steps. So just to give you an overview of the life cycle that generally we've implemented at each step. So we'll start on the right there with design. So this was primarily where you would be able to check out your process, analyze your processes and maybe create a process model to actually model your process. This is something done by an analyst or a technical lead or something. And at this point, it's where the model becomes, using the BPMN standard notation, the model actually becomes something sort of true to exactly the process it's trying to execute. So next up is the implementation. So that's where a developer would take that model and then implement what the model says to do. So for instance, create Java classes and things for service tasks, or create UI for the user tasks, that sort of thing. And that's done within the Eclipse modeler, which I'll be showing you as well. Finally, in operation, that is where we can sort of see the process in action, where we can act upon the process, where we can check out various details of the process in Cockpit. And then, of course, finally, analysis, where, again, Cockpit is utilized in order to find out information about the process you've created, about whether it's actually working the way you intended it to, and that sort of thing. Okay, so that is all the slides for now. So I'm going to open up my trusty Eclipse. If I can find the mouse, which I can, there we go. And I'm going to create a project here for this demo. So I'm going to be using Maven to create the project. So Camunda has these Maven archetypes available. These make creating a new project really, really easy. What we've basically done is, using this Maven archetype, is create a project that then has all the requirements and dependencies that you're going to need to run the project. It means a lot less tinkering around with your Java project. So I'm going to type in org.camunda.demo.web, and I'm going to call this demo web, and click finish. So along here somewhere, hopefully, there we are, alive and well, this project will start being created. So of the many things that what this Maven archetype has created is a process model, which if I open will show you the Eclipse modeler that I mentioned. And if it does open, well, I'm sure it will. It's also got the POM file down here that has all the dependencies required to build this project, and as well as the beginnings of a testing suite. So we have a very extensive UI for testing processes. You can actually run our engine within Eclipse in order to test processes, so you don't have to deploy them anywhere to check if they work. So let's see, to give you an example of what this is all about, I'm just going to create a single task in a process. So this is a service task, which means that it's going to require some sort of code to run. So I'm going to say run some code. Alrighty. So now this Eclipse modeler is a little clunky, and it's essentially made for developers, because it's got this very important properties panel here. So when I click on this process, you can see it's giving me the option to select a class and an expression. It's also got loads of other sort of fun little things you can do to manipulate this in order to make it executable. Now, as it happens, we do have another modeler, which is more intended for analysts, which I might just show you now. Let's see if I have it open. Yep. So there we go. So this is our BPMN IO modeler, and I'm just going to open the file that I just created. So should be demo web, and it should be in main resources. Here's our process. I'm going to open that. So here we have a very similar model. The XML that's produced in both of these models is identical. It essentially follows the standard, so it's completely transferable to other modeling tools, and no data gets lost. So in this tool, it's a lot more user friendly. I can it's more geared towards designers for now. And I can do stuff like remove this. Maybe I'll create a this little gateway there and make this pool bigger and just get more space. So then I'm going to create another task up here, another task down here. I'm going to join those together. And then I'm going to end the task. So what I'm going to do here is I'm going to create two user tasks. So this will be, let's see, user, what do we do? Go north. And this can be go south. And this is also a user task. So just to explain what's going to happen here and what this, for those who may not be familiar with BPMN as a notation. So when this starts, when the process engine starts this off, it's going to come here. It's going to find out what it needs to run at this point, what kind of code. It's going to run that. I'm going to come to this gate. This is an XOR gate. So it's either going to go up or down, depending on, let's say, a variable that's created in here. And then a user will be asked to act on one of these. So I'm going to save this and then load it up here. Yes, do you want to save changes? I do not. And I'm going to open that up. Alrighty, and there's our, just a quick note, actually, I should probably mention that this is also available so I use the desktop version there, but the online version is available here. You can click try online there, create, and it's exactly the same modeler, except that none of the data is stored anywhere. This is totally just in the browser, the same functionalities. And yeah, so that's all. That in case you want to try that out later. Alrighty, so now I'm going to just show you guys how to actually go about making this thing executable. So we have our model that's created, and now we actually want to turn it into something that a program can run. So I'm going to create a Java class here, and new class, and it's going to be called random class delegate. So the reason I'm calling it delegate is because the one little thing you have to add to this is to implement a Java delegate interface. So once I click finish, I'll show you what exactly I mean by that. Okay, so random class is opened up, and here it is in all its glory. What it has done is it's added this execute method. I won't get too technical in this, so don't worry now you've seen code. This will be a very quick foray into Java. So this execute method is run when the process engine gets to this class. And this little execution variable here is what contains all the data that you're going to need, that you might need to take variables out of the process instance and even put variables back in. It also has loads of other functions and will give you access to other Java libraries as well that involve the process engine. Now, rather than actually writing something in any way complicated, I'm going to copy something I did earlier, which is a really simple little bit of Java that produces a random a variable called north. So again, very quickly, just to tell you what's happening here, I'm using this random method to return a true or false value. And then depending on if it's true, then I'm just going to set a variable north true. And if it's false, I'm going to set the variable north to be false. So this is going to put the variable into the process instance. So now for the fun part of actually attaching that to the process engine, which is not complicated at all. It's going to be a class. It could be an expression, of course. And I'm going to just try and remember random class delegate and click OK. And so that's basically it. That's pretty much all you need to do. So the last part of the execution is going to be the fun part where we work out how this gate is going to react. So in that case, I do already know from this class here that I'm going to have a variable called north, and it's going to be one of two things. So I am going to use a conditional expression to say if, pardon me, if north, actually this is probably sad, so maybe not north. If not north, then we're going to go this way. So in this particular instance, I'm using the Java Unified Expression Language, so Joule. That's the default scripting language for the engine. But you can see here we do have a conditional language, so we can have other languages that can run on the JVM. We also have condition source, so if you don't want to have to write a script onto the model itself, you don't have to. You can point it to the source class. Alrighty, so now I'm going to go up here and do the opposite. So this particular guy is going to, pardon me if I click on him. This is going to do the opposite. Again, this is just going to check that variable is true. And actually, that might be all we need to do to make this executable. So I'm just going to use Maven again to create the deployed process. If all goes according to plan, this should say build successfully at the end. Aha, it was a success, as I predicted. And this is what we're left with. We've got a WAR file here with our project all tapered in. So I am now going to deploy that. Now, I actually have a server running right now that I started before this webinar, and you can download this at Camunda/downloads, camunda.org/downloads, and it's just it's a wildfly distribution of the platform. And you can see here, this has got the task list, which is for users who are actually are given work to do by the process. So it's human workflow. And we also have operations and monitoring in Cockpit, as I mentioned. So right now, if I were to go to Cockpit, I should see the invoice process, which is the demo process that comes along with the product. So now I'm actually going to deploy our article process that we made. I'm going to do that by, pardon me. I'm just going to open up the, so I'm going to find the Camunda distribution I'm using. I'll just drag that back over here. So yeah, so here's the distribution. I essentially got this. I unzipped this file and out came all this fun stuff. So I'm going to go into server. This is a wildfly, as I mentioned. Standalone deployments. So here's where all the fun stuff is. I'm also going to just deploy that in here. And Camunda should pick that up and notice that it's got a new process, and there we have it's deployed. And if I refresh Cockpit, we should have our demo process. So all's well so far. In fact, probably a little easier to see as a preview. And clicking on here, you can see we have the first version, and there's nothing particularly happening with it. So let's start something off. And to do that, I'm going to go to task list, where we should only just have some little demo instances. I'm going to make this full screen so everyone can see it. So this is our little task management tool and UI, and we use this to communicate through the to the engine about what tasks are going on. So one of the things we're going to do is we're going to start our new task. So web demo. I'm going to give it a fun business key of 1, 2, 3, 4. And here we go. We got go south. So that was quite quick. We can check out the diagram here. You can see exactly where we are. We arrived there somehow. And you can also see if I click on form, it doesn't actually have a form. Instead, what we actually have is a sort of a developer's form in which you can create a variable. This is for prototyping and stuff. There are better ways of doing it, which I'll show you very shortly. But for now, I'm just going to complete this task and maybe start a few more just to see how many I can get going. So start. Oh, south again. I'm going to try and get some that go a different direction. Oh, we got north. Awesome. So I'm going to go back to Cockpit, and we're going to take a look at what we got going on now. So you can see the differences. Of course, we now have 2 running instances instead of 0 as yet before. And you can see they're right there. There's one in north and one in south. Obviously, we also completed one earlier. So if I click on the history tab up here, you'll see we have this little guy here. And he is complete. So I can click on him to find out what direction he went and what sort of variables he had. you can see if I click here, the north variable that was created was false, which is why he went south. Alrighty, so yeah, so back to the runtime. There's other bits and pieces that you can do in this in Cockpit, and I'm not going to spend too much time on the features, but there's some fun stuff, like for instance, if you're more of a I'd like going north sort of person, you can always select, let's say this guy here, and you can move this process instance to wherever you like, to gateway or to another. We'll move it up north, and and I'm going to add modification and proceed. Now, what that does in task list is that we currently, as you can see, have go north and go south. But if I click on that, we have 2 go north tasks now. Now, the nice thing is that that's all stored in history. So that isn't just something that can randomly happen by some very click-happy admin. This is, you can see through the history, if I look on the side here, that I started on the start event. I went to run some code. I got to this gateway. I went south, and then you can see there the activity was cancelled and reappears north. So that's just some of the quick features about Cockpit. But let's go back to our process, because we also have no UI, which is a bit of a problem because generally people like to have buttons to click on and whatnot. So I'm just going to quickly show you 1 or 2 of the ways that you can attach UI to a task in Camunda. Now, I'm going to be demonstrating how to attach UI, sort of like a form to an embedded form specifically that will show up in task list, but that isn't a restriction. You can also have external forms launch from particular tasks. So in this case, I'm going to go with the easy option, which is I'm going to click on form fields. So this is designed for prototyping. It's not particularly powerful, but here's what you can do. You can create a variable, let's call it name, my name. Actually, maybe I'll just have this my name as well, and I'm gonna call that a string. Alrighty, cool. So next up, maybe I'll add another variable, a boolean. Maybe sure. Are you sure? People do make mistakes, and I'm gonna set it as a boolean. So what would happen then is when the user, as you saw in the user in the task list, gets to go north, they will see a field, a string for my name, and a tick box for are you sure? So now I'm going to quickly jump back down to go south, where I'm going to show you guys how to create the more popular and used in production method of attaching a form, which is using this form key field. So as it happens, Maven has very kindly created a form for me. So if I go into Web Apps Forms, you can see it's got a task form right there. And what this is, it's just some HTML. We have our own little variables here so that you can retrieve and put variables into the process instance very easily within the form. It actually has a really nice API, and it's worth taking a look at docs and camunda.org to find out the full abilities of this. But until then, I'm just going to type in embedded, because it's going to be an embedded form. It's going to be in the application, and its location is forms/task form, perhaps. Sorry, it's very far away. I can't read it very well. HTML, there we go. Super, so that's all I need to do. And now we're also going to have a quick lesson in versioning, because I'm going to be creating a new version of this process. I'm going to use the same before, Maven install, and create a brand new demo web. So assuming that I did everything correctly so far, another test pass, I do indeed, I'm going to grab this file again, and I'm going to put it in deployments. I'm just going to overwrite the old one. The override is popped into the screen, so just to show you. So I'm just going to overwrite that, and that is all we need to do, actually, because the engine is taking care of the rest of the versioning. So if I go back to Cockpit, for instance, if I refresh this, you will see we still have the 2 instances running from before. But if you click on it, those 2 instances are not there. Well, that's because up here you can see we have a version 2. If we go back to version 1, we still have everything as it was in all its glory and waiting to be completed. So basically, by default, all processes started on a certain version will also be completed in that version. There's other methods of migrating, and there's other ways of, for instance, you may decide during development especially that you don't want to keep the old versions because there's a lot of changes. That's just a simple change to the properties in Eclipse. So yeah, so let's maybe launch some more of these tasks. Let's see, web demo start. Web demo. North. I guess I kind of. There we go. That's south. So south here we have the Maven created embedded form, and you can see there's the list, and I can complete that. Next up, we have our really very simple my name form, which I shall give Naldian, which is my name, and yeah, I'm pretty sure. So that is sort of a very quick run through on Camunda and the modeler. I've only got a couple of minutes left before I hand it over to Daniel. So with that, I might just quickly go back to BPMN.io and show you a very handy little thing about the online version. And that is actually just kind of demonstrates how easily you can switch between a model, this model here that we just created. So I can drag this into the online one and then render it straight away. And the cool thing is that all the classes and the data that I originally set is all still there. It's all still in the HTML. And nothing gets lost by switching, let's say, back to the analysts to correct something or change something. You don't need to start from scratch again. You just need to edit the existing stuff. Okay, so I'm going to quickly go back to my... Actually, I'm going to go to my good buddy Daniel, and I'm going to stop sharing my screen. Alrighty, and I'm going to pass the beach ball of doom to Daniel, and he's going to be sharing his screen. And as I mentioned before, Daniel is a technical lead here in Camunda, and he'll be talking about how he integrated Camunda and Hazelcast this time last year, actually. So over to you, Daniel.
Camunda, I hope that people can hear me. Could you confirm now? That, yeah, thanks. Yeah, as I said, I'm the technical lead here at Camunda, which means that I'm the guy you complain to when the things that Niall showed you doesn't work or don't work the way they work when he works with them. No, seriously. Yeah, so I'm really excited to be able to talk about our little Hazelcast thing today and to be able to present our product to the Hazelcast community and users. So what I'm going to do is I'm going to start with a small story of how all this Hazelcast collaboration that we did came together, and then I'll go a little bit into the technical details of why we would actually want to use something like Camunda and Hazelcast together. Okay, I hope that my my presentation won't like break and stuff. I'm usually not using Windows today for the webinar. I do, so I hope everything works all right. Yeah, so let me get into how this all started. So at Camunda, we do a yearly hackathon, and last year we got together, and what we do there is that we have a team of developers. We also have our consultants. There are also people from the sales department that know how to write code, and so once a year everybody gets together and like tries to write code together. And last year, just before our hackathon, I had a call with 2 engineers who worked at a prospective customer of ours, and they were using Hazelcast in their setup, and they used it in order to implement a globally distributed task service. So they had tasks just very similar to what Niall now showed you in the Camunda task list. So they had a custom task service which is globally distributed, meaning that they had multiple data centers, and all around the world people could actually work on those tasks and complete them. And they were really like using Hazelcast for distributing all that and managing it. And I was quite impressed with the setup that they had. And since we have more and more people asking us about those kind of things, we said, well, let's try to do it. Let's try to port Camunda persistence to Hazelcast, and that's what you do. And so there was this one moment where we actually had the first test case running, and we were able to like start our process engine, not this time with MySQL, but with Hazelcast. And there was a really nice moment, and you see my colleague Sebastian here on the photograph exactly at that moment, and we put it on Twitter, and the Hazelcast people, they were pretty cool, and they replied to us, and so yeah, they were aware of us doing this, and that's how like this continued. And during that hack session, this is actually the cluster that we worked on. So the guy that you saw before in the picture, he's also I'm not sure what the correct term is for those people, but he collects those little computers right here, and you can see that he has like a Raspberry Pi and other kind of computers, and we had Hazelcast and Camunda distributed on that, running on that, and that's how we like got along those few days and use it. It was kind of exciting. After that, so we sat down again and we thought, should we like continue down this path or not? And what would actually be the benefits of using something like Hazelcast instead of a relational database? And if you look at when you use a relational database with Camunda, what you have is you have a cluster of replicated Camunda engines, and the Camunda engine actually maintains no session state. So when you deploy a Camunda cluster, you have multiple nodes running the process engine, but they will not actually maintain any state. So whenever we start a new process instance, the process instance advances to a certain task, waits for a message, waits for an event or something, all that state behind it is stored in the database. I like to say that a process engine isn't actually good at doing anything but waiting and continuing. So, and the waiting is actually done by the database. So yeah, so the database is a central part of the architecture of such a process engine. And if you look at the way we use relational databases, it's great, it works, and we have many people using that, and they're quite happy with it. But the challenges are, of course, you end up with this central resource. So while you can cluster and scale at the application level, so basically deploy more nodes running Camunda, at the end of the day, you cannot boundlessly scale your relational database. So you kind of end up with this shared resource that is a challenge to scale. Let's call it a challenge to scale. Then you have those questions of resilience. So what happens if this central database goes down, has a hardware defect, whatever? There are ways to deal with that in relational database. There are also good ways to deal with that. But usually what you see is that it's not like what people running relational database, what they think of as like their default thing. So they don't put backups in place, and then at some point they notice, and then they put it in place. But it's not like a relational database by default. It's not replicated by default. It's a single thing. And then we have this challenge of replication across data centers, which was what I said before. I talked to those engineers at that prospective customer, and while you can do that, there are challenges when you want to replicate something like Postgre or MySQL across multiple data centers, availability zones, etc. And something like Hazelcast then comes in, and when you use that as a persistence provider for a process engine, it's actually pretty cool because by nature, by default, it's already clustered. So it's not like you put in like a single instance by default, and then when you run into trouble or when you have problems, you put in more instances. But by default, it's just clustered. You're just going to have more instances. And when you do that, you actually also realize that it's not that big a challenge because it's it's really easy to set up and use like this. And this is what attracted us to using Hazelcast with our process engine, and that's also why we did this prototype and developed a persistence layer for Hazelcast with Camunda. And it works out, this is actually a good match because when you think about it, as I said, Camunda does not actually maintain any state, any session state on the individual nodes. So when you deploy the Camunda process engine as such to a application server, it won't take a lot of main memory. So there's lots and lots of free memory on those machines that can be used. So you can actually run the Hazelcast nodes on the same machines where you also run the process engine. And then you get those really nice behavior of many of your storing and loading calls of data will be local. So because it also acts as a cache, and in this way you actually use it as a cache. What is also important, Hazelcast supports transaction. So the process engine, it has to ensure fault tolerance and consistency. So when we advance from one task to the next in the workflow, what we need to make sure is that will not be one atomic state update, but it will be canceling activity instances, creating possibly multiple new activity instances. There will be variables created, variables deleted, variables updated. There is a very rich data model behind this, and you want to make consistent atomic updates to this. Of course, you can think about the data model. Should all the data related to a single process instance be part of the same object? Should it not be? We went with a more fine granular and powerful data model. But the cool thing is Hazelcast really gave us choices there because they support transactions and you can use them, and it worked out quite nicely. Hazelcast also supports indexed search, which is good because we have requirements like message correlation, where a message comes in and needs to be correlated based on data. And for that, the search is a very powerful way of implementing that. So really, Hazelcast, it supports the feature that we need in order to run a workflow engine. It's pretty good suited as a persistence provider. Also, something else which I didn't put on this slide, but usually you have different kinds of processes. There are those where human participants are involved, but there are also those that only do message correlation and message-driven orchestration. And if you have those kind of situations, usually your workflows won't last very long. So maybe they will not wait for hours, days, and weeks for the next message to arrive. Maybe they will run through in, I don't know, 5 minutes, 10 minutes, 15 minutes. And for that, something like a cache may be a very good persistence provider. So can you actually use this? The answer is yes. I'm going to show you how very quickly. On GitHub, we have a small project which is called Camunda Engine Hazelcast. You can use this. There is a single Maven dependency that you include in your Java project. If you do that, it looks like this. So you add this Camunda BPM extension Hazelcast, and then you're pretty much all set. So this is a very simple Java project. I'll just add a new class. So let's call it server. Why not? And I'm not familiar with this Eclipse. Okay, so let's put in a main method. Say new Hazelcast process engine configuration. We'll use the default configuration here. So now we could actually configure the Hazelcast connection. So we could now say connect to some kind of Hazelcast instance, stuff like that. But for now, we're just going to use the embedded one. So we'll just have a process engine like this. And then you can actually deploy something. And I'm not going to be as fancy as Null before, so I'm not actually going to model this graphically. I'm just too lazy for that. So I'm just going to use the Fluent API DSL for creating the model. And my model is going to be even simpler than the one he had. So I'm just going to put in a start event, a receive task, waiting for a message, and an end event. And that's my process. And we'll have to deploy that. And that's it. And now I can actually start this. And I forgot to give it an ID here. Let's call it test process. And now I can reference this here. And there you go. That's all it takes. So this will actually start the process. Then the process will wait at the receive task, and I can signal it. So because I'm running out of time a little bit, I'm just going to show you that it actually waits there. Then we can signal it later. So let's do it like this. Oh, actually, we need this runtime service again. Oh my god. So this actually gives me the this current state of that process. And we're going to use a debugger and look at that. Okay, so already in the Eclipse console, what you can see here is that the default configuration of the Hazelcast process instance will actually start Hazelcast 2. It will build a cluster of one node, and you can see here that we're going to start Camunda, build the process engine, etc. And now going back to our code here, what we can see is that I have a actually this seems to produce an error. Very good. Let's see what the problem is there very quickly. There you go. Found it. No, again. It wasn't so hard when I prepared. Okay. DOM document is not valid. So why isn't it valid? Let's give it a quick look. And if that doesn't work, you just have to copy it from the README of the process. So what did we mess up here? I don't know. So we'll just have to. You just have to believe me that it works. You can actually copy it from here, and then it will work. So yeah, I just messed something up. But the take-home message is that it works and that you can use it from that little project. Now, as I said, this is on GitHub. This is actually a community extension. And currently it's looking for maintenance. So if you are excited about this and want to collaborate with us on this, we have that community extension program where we give community members the opportunity to take on projects and take care of them and collaborate with us on them. This is one of those projects. So if you feel appealed to work on the Hazelcast project, this is actually up for grabs. Great. So that was my little introduction to the Camunda Hazelcast extension. And with this, I'm passing the ball back to you now.
Hey, folks. So I see that we've got a few questions already. But before the Q&A, actually, in fact, if you guys have any questions, please just add them into the QA section there, and I'll try and get them in about 5 minutes. Until then, I'm actually going to go back to my screen briefly and maybe discuss a few more slides in the about the platform. Sorry, I'm doing two things at once, which I'm bad at. Okay, good stuff. You should be able to see my PDF again. So here we go. So yeah, so just to go back to this diagram again. So we've seen how Daniel there was communicating with the engine via the Java API. Well, it's also really important to notice that the Hazelcast connection there is also available, as well as loads of other types of databases, and we can have Camunda inside of various different containers: Tomcat, JBoss, Glassfish. I happen to have it, of course, in Wildfly. You can also, one of the most interesting things and most often used and enjoyed feature is that the engine is completely separate from what you guys saw earlier in task list and cockpit. So for instance, everything you saw there, everything you saw about me dragging and dropping the token, and everything you saw in task list of completing forms and that sort of thing is actually just REST communication with the engine. So that is so that means that what we show there, your custom application can do exactly that with the engine very easily through a pretty long and REST API that can do absolutely everything. The REST API is based on the Java API, meaning that if you guys also wanted to write an application that has the engine embedded into it somewhere, you could just communicate via the Java API, maybe a little faster. So other interesting things, of course, being that the engine can access all sorts of different kinds of file repositories, similar to any kind of repository you might have for coding and that sort of thing. We also have a lot of different third-party modelers that we can, as I mentioned before, Cycle can keep synchronized with what the engine is reading, and not obviously live, but in the development process. And yeah, so as I said, any questions, pop along there in the box. Finally, before the questions start, I just want to discuss briefly what kind of people use Camunda. Who are the people who are using it? Well, it's the vast majority of them are in Europe currently, because that's where we're based, and that's where we've been since this platform launched in 2012. And you can see there we've got a lot of insurance, finance, and telecommunications companies. We're starting recently to sort of have a lot more Canadian and US customers, like Sparta Systems and iTrade Network at the top there. And so, if just in case you're wondering what sort of guys we also have more sort of widely dispersed customers, like Allianz in Indonesia. And we have Australia. We have the two companies in Australia as well. Okay, so I think that leads me nicely to thank you. And I'm going to stop sharing my screen now and maybe try and answer some of the questions that were sent. And okay, so. So let's see. Great. So I'll try and I'll let Daniel look through those as well. If you see any you like, Daniel, just throw something at me, so I'll let you speak.
Yeah. Am I on? Okay. Yes, there was. The first question I saw here is, I am going bottom to top probably. So it's, do you support a full BPMN specification? The answer is no. So we don't have coverage for the whole BPMN specification. We have a very good coverage, I'd say. The details can be found in documentation, and I'll share a link to the coverage of that. So there you go. And yes, just like, because I have to say it, because we just finished it yesterday, there's also now support for escalation events. So that's obviously missing in the documentation for the latest minor release. So escalation events are also supported. And the second question here was, or the second part of the question was, can you talk about the single event support? Yes, single events are part of that support. And you can use both catching and throwing signal events. Niall, do you have a question? Do you see a question here you want to answer?
Yeah, sure, why not? Well, an interesting one there is BPMN.io is intended for BPMN.io to replace the Eclipse modeler? And yeah, that is the long goal. All right. Currently, we have the two modelers. We have the BPMN.io one, which is lovely and fancy and great for usability. And we have the Eclipse modeler, which focuses more on developers and the environment there. And we kind of want to do our best to make things easier for the people who have to make the models, which is why BPMN was started. But also, we really want to make the Eclipse modeler a lot nicer, because if you're a developer who also creates these models, it's using Eclipse. Having it in Eclipse is really handy. It's in your development environment, but also having it be restricted in its usability because of Eclipse is not very handy. So the goal eventually is to have BPMN.io perform all the features that the Eclipse modeler does, including all the executable stuff. And in fact, we should. The general plan is to have BPMN.io open up inside Eclipse in the same way the Eclipse modeler does, just possibly something like going to the website or something. We haven't really decided how that's going to go, but that's on the cards, all right, yeah.
Sorry, yes, there's a question here, and that question is, what's the current status of the Camunda Hazelcast project? So what's the functional status? So I suppose that the question is about, like, does everything work with Hazelcast that works with a relational database? At the moment, no. So the feature set is restricted. So there is a good baseline of things that work. Things like complex queries are not implemented at the moment. For example, if you look at our task API, task management is 90% about search. So like finding the right task, right? So you want to search for tasks by user, assignee, groups, priority, and you have all those like complex combinations for that, and stuff like that isn't implemented on top of Hazelcast yet. It is an open question. I honestly, I don't know whether that's even a good fit for Hazelcast. Sometimes we also question whether that kind of API is a good fit for a relational database. So far it works. But maybe that is also a use case for some completely different persistence technology. We don't know. But so for the moment, there are limitations of what you can do with the Hazelcast extension. The basic set of features like starting workflows, having them wait in a user task, having them wait in a catching message event, and then sending the trigger back in. So that basis, that is a workflow engine along with data and variables works. And yeah, you can take it from there.
Yeah, I see a question there that's going to be very easy for me to answer. Signal events again. Are they supported through interprocess and intra-process? And yes, they are. A signal event is not scoped within a single process. It's scoped through the process engine. So, yeah, that's how signal events work. So anything that's listening for a signal will be picked up by that. I think there actually might be a code example in that on GitHub somewhere, and I know I created one. Whether I put it on GitHub or not, I can't remember. But I will. That at least reminds me to do it if I haven't already. So we've got about 5 minutes left.
There's one additional question here. Does Camunda provide a store implementation for Hazelcast, or is it all in memory? Honestly, I'm not sure, because I don't know Hazelcast enough to know whether that works or not. We don't provide something custom. If that's the question, the answer is no. But if that is something, I could imagine that Hazelcast just has file system or other kind of persistence, and that is independent from whoever puts in the data, then the answer is yes. But we haven't anything custom there. So yeah, I cannot totally answer it. Maybe some of the Hazelcast people can answer it. I'm not sure.
Yeah, true. Maybe you're not that qualified for that particular question. Yeah. So yeah, I think that that's probably cutting it close for the amount of questions we can answer in the time allowed. So I might pass it back to Ben now if he wants to wrap things up. You can always contact us here at Camunda if you have any other questions or you're interested in maybe doing a POC, or you're more interested in the engine or have questions about that. We're in all the usual places, and the first place to start, of course, is camunda.org. So yeah, Ben, if you want to take it back off me, you're more than welcome.
Great. Thanks so much, Niall and Daniel. I really appreciate your time sharing your knowledge and telling us about Camunda today. And just to let everyone know, there will be a recording of this webinar up on our website once we have time to process this. So you'll be able to access that and also share it with anybody else who might be interested in this information. I want to thank everyone once again for attending the webinar, and have a great day.